Hello, welcome to CAD in BIM, how we train civil and structural engineers. In this tutorial, I'm going to show you how we calculate bar bending schedule, or how to prepare bar bending schedule based on BS 8660. So without wasting much time, let's get started. If you recall in my previous video, I had just introduced the concept of calculating steel rebars. However, this was just a joke. It cannot be applicable in real life examples, just to notify you. So what I'm doing today, it's the real deal. This is the actual works that you as a structural engineer will be expected to do, and this one will give you very accurate results. So it's a very important topic that you have to watch to the end so that you don't skip anything. So these are the slab that you are going to use, but for in some other cases you could be provided with a PDF example like this one. You can see how complicated or how detailed it is. So maybe you are tasked to calculate the bars or to estimate the number of bars that are in this slab here. Let me just zoom it in so that you can see. You can see it's more detailed and it will not be a 1+1 task. And maybe you need to do this and more accurately and professionally. So this is what I'm going to look at in this tutorial, and I believe it's going to be a very important tutorial. So once you are given like this, as I told you, we are going to base our works or our estimation or preparation based on BS 8666. So you have to arm yourself with this Excel sheet here, which is just was prepared based on the same. So you can see this is the Excel sheet. Maybe if it's not clear, you can see. So this is BS 866. You can see these values here. They are the values on this. Let me just show you here. Let's go to page 9. You can see these the shape codes here. These shape codes are similar to these shape codes here. You'll soon understand how they come into act. Actually, this is how you can bend most of your bars on site. So there is the idea of bending these and how the length will affect the length and how to calculate this. It's all documented in this BS here, and they are showing us in table 3. For instance, I'll just show you that table 3 here. You can see these values here. They are what I'm showing you. They are recorded here. So minimum dimensions that are allowable for maybe links, angle length, two bends, and such things here. So once you have you are tasked to do this, you just open your Excel sheet here and you open your drawing. So for my case, I'm just opening my DW drawing here that you're going to use. So the first thing you do is to identify the bar marks. So simply identify the bar marks here, just as I've done. So for my case, I've just identified bar mark 23 to 29, but you can see you start with the smallest, you write them in ascending order. 23, it ascends to almost 50 something here. So if this is 26, 27, or you have 42, we have on this side 45, 49. So on this side we have 20, 20. So you have the lowest here I can get 20. So you can start with 20, 23, 39, like that. So you arrange them properly here. So you ought to have started with 20, but for the demonstration, let's take 23. Then you record all your bar mark, and then you come and record. As you record your bar mark, can identify the type, maybe the size of that bar mark, the number of bar marks if they are repeated. For instance, in our case here, 26 bar mark is repeated twice. You can see this 26 here and also this 26. So meaning that you have two members of 26. So once you come to your Excel sheet, so you record bar mark 23. Bar mark 23 is only a single bar mark or a single member here. See here they are small. I hope you are able to see. So this 23. So having 23 there, you record it here 23. It's just a single member. But for 26, just two members. So if they have repeated bar mark, we don't do 26, 26, just check, play with here, just add it, maybe three members, two members. And then you come and say number of bars in each. So number of bars, this is if there are 20, you just write 20, 29, you can say I've recorded. And also we have the other one for 26, which is 31, I've already recorded. So recording them means that just observe and record them accurately. Let me just be. Yes. So that is it. So you can go ahead by recording all those information and then you come to shape code. Shape code, you can, based on how they are bent, you can either find it's a straight shape, maybe has gone by one, maybe it can be bent once like this. So you can also get this 42 like this one here. So for our case, we had bar mark 23 is bent, like has the shape code of 41, whereas 26 has shape code number 1. So let me just, can see the shape here. I hope it's visible. And now if we come back to our shapes, so for maybe a DWG dimensions will be given, but if they are not given, you can always estimate, or you can just dimension, like in have just dimensions. So this A, this shape A, this B, let me just show you again so that we are together. So this A, this length here A, so A here will be 1285, 1290, because you have to give them in multiple according to the BS in multiples of 5. So this one will be 1290. B will be the depth of that slab, which is 100. Then C will be the longest length, and then we'll also go up by the depth of that slab is 100, and also you'll get this is 100. You can see what I mean. So that's how you record A, B, C. So once you come in your Excel here, record all of them. Record where you have A. If I have with them my Excel, so come to your schedule, record where you have A. Record where you have maybe A. Record A, B, B, C, C, D, and until when you have E. For bar mark 24, each shape code is 13. Shape code 13 looks like, let me just show you shape code 13. This shape code 13, so it will have A, B, and C. So that's the only thing that you record, which is A, B, and C. So let's go to that shape code in there. So that is a bar mark 24. You just come here with this 24. Here it is. So you can see it here. So it has A. A is the longest part, which is 9340. Then you have B, which is the depth of that slab, which is just 100, and then you have this one which is bent, which is 687. So you can say 690 or just 700. So I hope now you have seen how to fill. So that's how you go. If it's just a straight bar like this one, bar 25, let's just go back. So that's bar mark 00 here. Bar mark 00, just record A. How do you get your A? Just go to your go to your drawing, either in AutoCAD or in the PDF. Look at bar mark 25 here. 25, no, that was 25 or 26, 26. You come, it's just a straight line, this bar mark A. So this you just get this length, you sum these two numbers here, then you get the length and you come and record it. So I think now once you get you want to fill your data properly, then it will calculate automatically. The Excel sheet will calculate for you. Let me just do it. Yeah, Excel sheet will calculate for you the weight. Actually, you can see, for instance, let's say we had bar mark, not bar mark, if maybe I had used maybe 10 instead of 12 in slab, you can see that the kg has changed here. Let's see. So once we input 10, you have 1 or 2.96. And what happens once we input, let's say now 8? Let's change this one to 8 and see. You can see it has reduced to 66. Same. So you can see this is an automated Excel sheet. So it will really save your time. Maybe if you changed your length or anything here on this Excel sheet, because you are interested with the kg, it will automatically change here. Having noted that, so once you fill your Excel and it is full here, you can always create a fresh Excel by simply saving this, and then you open a new sheet and then you clear the data and continue. So once you input all your data, then you can transfer this data into presentation, into a normal Excel sheet. Like you can see how we have prepared these slabs here. So what's the most critical information? You have the bar mark, you have the size of your member, you have the number of those bent bars for each type of bar. You have the length in millimeters, your total length, which is now each length divided by the number of bars. You can easily now calculate the number of bars, 12-meter bars that will be got by simply dividing total length divided by 12. Get it here. You can simply insert your formulas here. You can see, and you just make your work easier. You have the shape code to remind you how the bars were bent. You have your total weight and you have your kg. So with this information,